So hi everyone. I forgot to upload a video yesterday. So how my day three went. So on day three, what I did was I did not focus on JavaScript or React. I got too much involved in solving lead code problems. I have an upcoming Google interview in around. So how much would it be? Last week. So last week of Jan it is. I don't want to disclose the date exact, but yeah, so this is it. And so the update is like day before yesterday I was here at binary tree right side view. I haven't solved it yet, as I told you guys that focusing on finding a pattern to solve all kind of tree questions. Okay, so for that I found that that pattern works for diameter of binary tree. It's an easy question. And binary tree maximum path sum, it's a hard question. And we can for this one there can be one variation as well, where you can like for this problem it is any node to any node, and one variation could be leaf node to leaf node. Okay, so that pattern fits this these questions. Okay, uh, okay, I'll come to that later. Let's see what all other questions I have solved. Then there was this watering plant question. It was a medium level question. It was not that complex. It was like there is an array, and uh, there are some plants, and the cost of moving from one plant to another plant is 1. So basically we were moving like this, and we had a can which was whose capacity was given. Okay, and then you would and these row would have the and these indexes would have the value of how much water a plant would take, like suppose 2, 3, 1. And if we have a capacity of 6, then we would go like we'll spend 2 liters of water here, then we'll come here, we'll have 4 liters of water left. Okay, so we spent 3, we'll left with 1, so 1. So the total number of steps would be 1 plus 1 plus 1 equals to 3. And if it is like the water, the amount of water left in the tank is less than the amount of water which is needed here, we have to go back to the -1th index and pick up water from there. And so obviously if you're going back there, the number of steps would be 1. Sorry, we'll just go from here, not from here, because we'll know that when we are here. Okay, so 1, 2, 3, then 4, 5, 6. So basically six steps would be added, and then the amount of water which you will be taking is the capacity of the tank. So basically when you come back here, we'll see, okay, here you have to fill 4 liters of water, then you'll empty it, so it will become 2, the capacity of the tank. So I mean, this was the question. There was no DP graph or anything, just a basic maths, but logic was there to be built. And and this was a medium question, so this was done. Then we have this maximum average subarray. This may sound very complicated when we see that it's a subarray, but it was not, because what you would have to do simply is simply do it like this. You pick up this subarray. You'll be given the size k, like for what's the size of the subarray. So you'll start from here. You'll take sum of k length, and then you'll keep on moving this to the right of it, and you'll have the summation of all the values inside this array, inside this range. Okay, Now you would simply go ahead, and if you move one step further, you will add this index. Suppose if you are here, I, this last index, you would simply do is sum plus array at ith index, and you will minus this value, the first one of this range array. And suppose if it is I minus k, then this one would become I minus k minus 1. So I minus k minus 1. This will be the answer. And then you'll just keep on comparing this with a variable which is max. I mean maxi, suppose if you take, so max of maximum comma this value. Okay. So at the end of the day, when you have traversed the whole array, you will get the maxi value. That would be the answer. So yeah, this is all which I did yesterday, and yeah, I'm currently working on getting you the pattern using which I can give you the solution. I mean, using which you can solve any tree problem easily. So currently the thing which is like for solving these problems, diameter of binary tree maximum path sum. Okay, let me tell you how to do that. You would simply start with the integer. Let's say solve tree or something. We'll say we'll get a tree node star root. We'll also send some result value. This thing will be global, okay? When there will be a main function from where you will be like setting this to be anything. I mean, let's take an example int minimum, and then you're calling this function solve tree with the root, and you might have also created this. Okay, this is where we have created. So you will just simply send it here, and we are sending it by call by address. Okay, this is very important because when you are updating it, you'll just update it here in all the calls, and then you will simply return the response. Oh, sorry, I'm really sorry. I'm calling it response again because I've been doing web development. So you know how when we fetch API data, we save it as res, and this is what we call response. But here, obviously, I mean result and not response. Okay, so let's head back to the function. So the very basic thing which you will need in all these problems would be a base case. Okay, and then you will need some hypothesis. So base case would be suppose if you are calculating the diameter of a tree problem, you would do is if root equals to null pointer, you would simply return 0. All right, this would be the base case for diameter of a tree, or maybe if you want to calculate maximum path sum, in that case also we'll be simply returning 0 in this case. So basically if you are at the root leaf node, okay, and from here if someone is going down, this should return 0, okay, because we are not getting any value that can be added up to be as diameter, or we are also not getting it as like something that we could add into maximum path sum, because obviously null is like we are not getting any value from here to be added to make it as a part of maximum sum, correct? So yeah, this is what the base case would look like. Now hypothesis. So hypothesis, in whenever you're solving any recursive question, how would you assume, what is the intuition behind it? Any recursive question you solve, you would assume that this this or every recursion call is giving you the correct answer which you would require at the end of the day. So you have to assume that each call is giving you the correct answer, no matter if it is giving you at the moment or not. You don't know anything about it, correct? So what you have to do is you have to assume. This is where the hypothesis comes into the picture. So you would assume that integer left equals to, which is nothing but this one. This is tree, this is a tree. So you are assuming that from left tree, from right tree. So left is this thing in this hypothesis. So left equals to, um, suppose you are solving it for the trees, so you would say solve, solving for the left one. So you would say solve, which is nothing but this function, solve tree, and here you will pass root left, comma, the result. Same goes for integer right equals to solve tree root right, comma, result. Okay, now hypothesis part is done. Now we have our answers. Okay, now what you can do is you can do your final calculation. Okay, for this you would I mean, there's a common pattern which I have seen, that you would need a temporary value, answer, and the result, of course. So for temporary, okay, first of all let me tell you how to see this problem. In the case where we are checking for the diameter, okay, so diameter is nothing but the longest path, which is this one. Okay, this is the longest path. Now let's look at this node to analyze how are we going to formalize our solution. So there could be two situations. Okay, first of all, one more thing is that a diameter is not, it does not have to necessarily pass through the root node. Okay, so this is very important. Otherwise people would think that, okay, this is the root node, it will always pass through it. Let me give you an example why it should not be the case. Suppose this is the root node and this is leaf node. So this is the root node. Okay, this diameter is having 1 2 3 4 5 nodes via root. Now let's see this one. 1 2 3 4 5 6 nodes, not via root. Okay, so you have to understand that the diameter does not have to pass through the root node always. Okay, now let's move on to the pattern which we were talking about. So in this scenario, what can happen? There can be two things which can happen. First one is this node will say, okay, I'm assuming that I'm not the answer node, and I mean answer node means that this is not the node which is having the answer. In this case, this node is saying I'm not the answer and I think the above one is answer, or anything other than me is the answer. So I want to be the part of answer, but I'm not the answer. Okay, so in that case, we'll say that this is a temporary value, and what will happen is it will say, okay, uh, one answer will come from left, okay, left tree. One answer will come from right tree. It will say that suppose from left we get the answer as L, from right we get the answer as right R. Okay, okay, this is what we did here, left and right. So we have this value of L and R. Okay, now what we'll do is we since it was a temporary case, it is not the answer, so it will say, okay, I'll take maximum of L or R, and then I'll add myself into it, and then I'll give it back. Okay, so it will say maximum of left comma right, then I'll add +1, which is the number itself, which is this node itself. So this is how it is adding +1. Now if we say integer, let's come back to if it was the case of it was the answer itself. So what it will do is it will say L plus R plus this himself 1. This will become the answer if he is thinking that I am the one who is the answer. So in case this node, he thinks that I am the answer, so in that case it will say 1 plus 2 plus 3 plus 4 5 6. So it will say that I'm the answer, so it will get from here 2, from here it will get 3, and so 2 will come from left, 3 will come from right, so it will say 2 plus 3 plus this node himself equals to 6. Now let's come here, we'll say maximum of this one and the answer, which was L plus R plus 1, which is nothing but left right plus 1. Okay, now we can say, now we can update this response equals to max of the current response we have and the answer. Now we can simply return the temporary variable, and this is it. This is how you can solve many problems. Wait, how to, okay, so this is how you can solve. There are multiple problems, so this will be the solution for diameter of the tree. Okay, same thing can be done for calculating the maximum path sum. Okay, now let me try how to change it to the to calculate the maximum path of the tree. So I guess this return value would be same, okay, because base condition, again we are calculating the sum. So if there is null, so we'll simply return 0, because 0 is something which will be adding in place of non-existing node, correct? So base case would be same, and again left and right, we are simply getting these values from the left and right subtree, that how much is the sum calculated so far for the left one and for the right one. So we'll again get this left comma right. Okay, now let's get back to temp, answer, and result. Okay, so for the temporary, what are we getting here? For temporary, we'll say again that max of L comma R plus, here we are not adding 1 because we are not adding the node, but we are adding the node value, correct, because we are calculating the sum. So what we'll do is we'll say root value. Now we'll come back to answer, remember I told you that what if it is the case that this is the answer itself. So in that case, what we'll do is, wait, let me take some space. We'll see if um, left, so we'll see that if left plus right plus root value okay, and we'll check for maximum of this temp comma left plus uh, comma left plus root right plus root value. Okay, and then we'll simply say result equals to maximum of response comma so result comma answer, and then we'll set return temp. Now here we can see that there can be a situation where the value which we are getting from left and right could be negative both. Okay, and we don't want to include any negative coming from the bottom, and we would simply want that we would check if the root is also negative or not. Okay, so what we'll do is we'll see here I'm updating the temp max of root value comma this much here, and this will do the job. So you can see that um, this simple pattern, solve tree base condition and assuming the hypothesis for left and right solution, and then like assigning a temporary variable when that node does not consider itself to be the solution, and then we have another situation when the node consider itself as a solution, then we'll update the response and then we'll return the temporary uh, value. Okay, so this pretty much solves all both of these problems. This will also solve one more problem where this solution was for any to any, and if we wanted to leaf node, correct, then we'll simply say we'll simply come here and we'll check if if leaf if node left and node right both are null, then only you have to consider this case. Okay, otherwise you don't have to. This one condition will solve that problem where you are switching from any node to leaf node to leaf node problem. Okay, yeah, so this was it, and I hope I helped you guys. I know it's very confusing and all, but I'm just starting. I don't know how to uh, explain it very well though, but I'll get there eventually. Just let me know what I can improve and all while explaining things, and I'm sure I can be able to incorporate all that suggestion into my next video. And until then, yeah, thanks. Hope to see you guys in the next video. Bye bye.